All right, thank you. So, yeah, Paul Lucey here. So I was going to talk this morning about the living labs and their role in research. So I was first introduced to living labs just over a decade ago when Data 61 was still called NICTA, and I had a living lab in New South Wales there. And I went over and had a look at it around the transport industry. And I thought that would be a very good model for what we were doing in mining at the time, although I didn't really understand what a living lab was back then. Although I've been involved in quite a few since then. And about 3 years ago, we decided to establish our own living lab. And this is about the journey around that, what we've learned, and some of the aspects of how you build a living lab and what that actually means in terms of how we now approach doing research and commercialization of that research. All right, so in the last 18 months, these are the organisations that we have spoken to in regards to living labs and how we would set one up in Australia. As you can see, we've had a fairly hard focus on the various CRCs, and that was because we wanted to create a hub for CRCs in the Pilbara region of Western Australia and see what we could do with a living lab in a specific region with as many CRCs as we possibly could. And with that, there's a number of universities we had discussions with at length. Now, some of these universities we have had a relationship now for many, many years that go beyond the living lab, and they've shown an interest in terms of assisting us in this process. So what is a living lab? So if you look on the internet, there's 1,000 explanations around what a living lab is. And so we've come up with this solution in terms of what we perceive a living lab is. And so that's getting the government, the researchers, the technology providers, the community and the end users together and incorporating that into the one ecosystem. Now, when we first started this, we put the mining companies, and this is going back many, many years now, in the technology provider component down here. But in the last few years, we've moved them into the user group. And as we go through this process, I'll explain why we did that and the impact that we're now having since we have actually done that process. So we slipped them into the same group as the community. So for those that don't know the basics of what a living lab was, and so this is going back a decade to when I was first introduced to them, how it was explained to me, and this is the European version of what a living lab was. So this is the Law of Diffusion. This has been around since the 60s, and there's been a lot of work done by Everett Rogers and Geoffrey Moore around this. I think everyone's pretty familiar with the bell curve. So basically what it says is that if you have a good idea that is commercially viable and it gets to the early adopters, there's a chasm between that and the early majority, and only 1 in 12 good ideas actually make that leap forward in that space. And the early works from the living lab suggested that goes from 1 in 12 to 1 in 4 if you follow a living lab model, which I thought was pretty good, although I didn't actually understand the mechanics of how that actually worked, although I'm pretty comfortable in how I understand that now. But that's the basis of a living lab, is to take research into the wider community with a much better chance of success. So I don't want to go into too much in terms of the science behind it, but there's a couple of slides that will help to go through this. So a lot of this is done using mathematical curves, and so what I actually want to show here was the 3 different major curves that you have. So the one standard curve that we all understand, this curve best represents the automotive industry, which when you're doing modelling is probably the best industry to actually get a good understanding of how all these things work. Mining is this curve here, so that's the heterogeneous population, adoption by a few wealthy individuals first, and income constraints for the remaining adopters. It has a very long and flat adoption curve, which we know in mining is to be relatively true at around 15 years. And the reason for that, I could do an entire 45-minute presentation on that alone. It's quite interesting in the way that it works. And at the far end here, this is the tech curve that you have. So when you start talking about the adoption of smartphones or iPads, this is kind of what the curve actually looks like. So this was important in our modeling of a living lab and for us to choose the right location, the right process on what we were actually doing. Now, the other curve I wanted to talk about when we talk about Gaussian curves here. And so this is another important one to actually understand. And so this is understanding where you need to be optimal on the curve. And so the example I always use is there was a study out of the UK about 5 years ago, which said the number of monitors that is the most effective for anyone to use is 3. And so I used to always run with the optimal +1 model. So when I was in mining, I had 4 monitors, but to be fair, I really only used 3 of them. And even today, now you have these ultra-wide monitors. So I have an ultra-wide monitor and then one other screen, and that's effectively probably the peak use that I can actually do. But the interesting thing is, every time I went into a remote op center, everyone had somewhere between 6 to 9 screens. And so I would go around and I would ask people how many screens they actually use. And I would say, oh, they use all of them. But when we had a deep conversation, they typically only use 2 to 3 of them at any given time. If you turn the rest off, it wouldn't make a difference. And when I spoke to the designers of those remote ops, they said, yes, but the customer expects us to have more screens than you'd ever use. So that gives you an indication of what the mining industry does. And there's multiple examples that we looked at all the way through to autonomous trucks, is that mining companies, particularly the big ones, like to be right up here. They like to have the best technology possible. So if I go back to the automotive industry here, and so this is some data from the year that the Toyota Hilux took over as the #1 selling vehicle in Australia in terms of features and choices that you actually have around vehicles. So although these curves here are representative, you might say that the Toyota Hilux was here and the Holden Commodore had slipped from being relevant to the Australian consumer in that space. It was no longer optimal in terms of what we do. And so for that, we look at the positive features and negative features. So a positive feature may be things like adaptive cruise control. Just makes your life a little bit easier and you think, wow, I want this in my vehicle, this is great. A negative feature is like when you remove the spare tire out of the vehicle, give you a can of foam. And so what automotive companies tend to do is they think, well, you rarely ever use a spare tire. So what we'll do is we'll take that out and reduce costs, and we'll give you a can of foam, which is, might be okay when you buy it, but when you have a flat tire, a can of foam does not always work, speaking from experience there. So that's kind of how we measure things going forward. Mining tends to be like this curve right down here, very flat. So you have a lot of negative features and you have a lot of positive features that you're not necessarily going to use. An example I always use there is mining software packages. If you buy a mining software package, chances are you're only ever going to use less than 50% of the features, but they're all there. And that's because of the wide customer base that you currently have. So they're the only curves that I wanted to highlight today as part of the Living Lab process, because they're important in terms of the journey we're actually doing. All right, so getting back to what we did in terms of a Living Lab, we started off with these activities. So this is from about 3 years ago now. Now these activities really haven't changed at all in this entire process, even with our learnings. These are the activities that we decided to focus on, and they're still pretty relevant today. I'm pretty happy with what we did with this. Now I'm not going to go through them all, but what I will highlight is the ones in italics. So proof of concept testing, develop a business case. So we do a lot of total addressable market models, and that really helps with our process and actually understanding the value of what we're actually doing. The impact of those technologies on other parts of the ecosystem. This has probably been the most interesting in terms of what we did. And then strategies for the integration of new technology into other cities, or other mines, as the case may be. Now, the impact on the community, this has changed a little since we started, and there's been a whole series of learnings in this process. And a lot of this was modelled off what we saw overseas, particularly in Scandinavian countries and in North America, and what we could actually do in terms of doing this in Australia, although Australia tends to be quite different. So in the Pilbara, you have somewhere between 12 to 15% of the population is Indigenous. So we wanted to ensure that we weren't leaving anyone behind. It was easier than we had expected to include Indigenous residents in the process. Mining companies are quite mature in that space. What we were unprepared for is the tribal nature of the traditional owner groups and Aboriginal corporations and how they impact on other SMEs in the town. So what we found, oddly enough, is that when we were bringing technology into the town, engineering company ABC would say, yes, we'd love to do this technology, but we'll only do it if you do it with us and not with engineering company 1, 2, 3. And what we didn't realize at the time that we realize now is they're supported by different traditional owner groups. So that was a challenge that we didn't expect, but it highlighted that if we were dealing directly with a mining company, we wouldn't have been aware of this challenge in terms of how we integrate that technology into the community. The other thing we learned from this process is that when you talk to a mining company about new technology, they're only interested in how it's implemented, how they integrate it into their organizations. And if they have a deck of cards, they'll only let you look at 1 or 2, and you better try and guess the rest. When you're dealing with the SMEs and the support industries, they put all their cards on the table, and they tell you exactly what it is and how they're going to interact with those organizations. And that saved us a huge amount of time in terms of getting technology into a mining company. And that was quite an interesting experience for us. So what did we model? We modeled a lot out of the US. So the reason we focused, so the basic model is European, but how we implemented is more American. And that's because the Australian culture sits somewhere between the two in that respect. So Smart Columbus was an interesting model for us. You know, we probably spent a lot of energy looking at this. And so they started off as a smart city winner. They started with $50 million. They turned that into 500. And they're well on their way to turning that into a $1 billion industry. So when people ask me, where should we go in the world to look at autonomous vehicles or smart city, I always point them to Columbus. It's the unsung hero in that space in terms of actually what they've done to that city. So anyone not familiar with Columbus, Ohio, it's a city about the same size as Brisbane. And in the last few years, it's really lifted its profile in terms of what it does with technology. So this is if you go to the Smart Columbus webpage, you'll see this here, and it says in the second point there that our city is our living laboratory. So when we spoke to them about how they went to begin with, they had all these plans that we're bringing in, and they put them into the community, and they had nearly 100% failure rate because they didn't communicate with the community on what they actually wanted, and particularly in some of the areas where they thought they could help. And so they had to restart the entire program, and this time go out to the community to actually understand what the key problems were and what they actually wanted in that space. So that's certainly something we took on board, and so we spent a huge amount of time talking to the community before we actually did anything and push our weird and wonderful ideas upon them. And I think that was a key learning for us. Now they have hundreds of programs. I'm not going to go through them all, but there's one I'm going to highlight, which will hopefully indicate how a living lab process actually works in this process. And so this was around electric vehicles. Now I like this one because we're doing electric vehicles as well. And so what they wanted to do was increase the rate of ownership of electric vehicles. So what they did is they set out a series of workshops and opportunities to drive electric vehicles. As you can see, they had nearly 12,000 participants in that process, and they had all this data around who was interested in doing this. We'll see that they identified where they thought the early adopters were in that process. So it was actually quite a reasonably well laid out plan. And so this is some of the data they actually got back from in terms of that usage. So you can see that in terms of vehicle purchase, they've gone from likely to very likely, and that's the difference between you know, in the future I may buy an electric car to the idea that my next car will be electric going forward. So when we look at this from a mining perspective, and an example I use there is if I was to put in 100 electric vehicles to understand the impact of mining, I'd have to just about do the entire mining community in Australia to get 100 vehicles out there. But if you do it in a closed ecosystem, like Karratha, where we're focusing on our living lab, 100 electric vehicles is not a big ask. And the challenges associated with that versus mining is pretty similar in that space. And once you've solved those problems, then it's easier to do it in mining going forward. So it was quite successful. They attribute the purchase or lease of 950 EVs over the last 2 years, which is quite incredible for the program that they actually ran. And so we're actually copying this model somewhat in terms of our electric vehicle program. And although we initially focusing in the town itself, some of the customers will be some of the primes in the region, as well as some dedicated mining electric vehicles in that process. And rather than go to a specific mine, what we're doing is we're doing a lease component where an electric vehicle goes to different mines almost on a weekly basis. So that way the vehicle gets used in a variety of different cases going forward. All right, so as part of this process, they have this smart highway connection. And so we came across this town, Marysville. Now this is, we're a year into our program now when we discovered this. Now the thing about Marysville is that it's almost identical in size to Karratha, and they were doing exactly the same program, except they were 2 years ahead of us in terms of what they were doing. Right down to the smart traffic lights and some of the outputs around that. Demographically speaking, Marysville is very close to Karratha in that respect. So we were able to give almost like a future view in terms of the success of what they were actually doing. Now, the value of doing this in, say, a place the size of Karratha versus a place the size of Brisbane is that if you put 100 electric vehicles in a city the size of Brisbane, it's very difficult to understand the impact. Whereas if you put 100 electric vehicles in a town the size of Karratha, it has a massive impact. And so you get to see how things move much, much quicker in that respect. So that was quite interesting in the success that they had. In fact, they had more success at one point in this small town than Smart Columbus was having with the hundreds of millions of dollars that they were spending in a large city. The other places we looked at, and I won't go through more, but I have some highlights here. So one of them was the city of Boston. So they have this old wharf district that sits between the financial district here, and you have MIT and university campuses down here. So what they did is this derelict area here, they set up with, they pushed all the autonomous vehicle companies into this area and gave them areas where they could go and test. And so what happened is they had a natural pool of pulling in tech companies from the MIT district up to here. And that was quite successful in terms of what we actually saw. And they had a good little ecosystem going there. And they had the support from the city of Boston, who was monitoring it. And so what we saw here was a mini living lab in a large city. And so we had some similar ideas of what we would do when we roll that out into a larger city. Now, I spent a couple of years in Pittsburgh, so a lot of the stuff we do is based on some of those learnings. And Pittsburgh is roughly the size of Perth. So this shows you, once you have it working properly, the way that you can grow an ecosystem and create jobs in this space. And so Pittsburgh, for example, in the space of 4 years, went from no autonomous vehicle companies to 6 autonomous vehicle companies, including Uber and Ford having their headquarters for their autonomous vehicle companies in the town. To the point that they had something happen in a 5-year period called Robotics Row. So it was an old derelict part of town. It's an old steel mill town. And all of a sudden, in a very short period of time, you had a huge amount of robotics and automation companies move in, and they all moved into this general location here. And so you had this place here called Lawrenceville. Now, 10 years ago in Lawrenceville, I would not walk through that place. There were whole streets that were derelict. Today, it's the hipster capital of the US. And so it's a bit like Fortitude Valley in Brisbane, or St Kilda in Melbourne, or Leederville in Perth, in terms of the people that are there. So it's been fundamental in terms of what you can do in that space. Now, the key takeaway from here in terms of what we did in terms of our learning of living labs. So a couple of years ago, when the Uber autonomous vehicle killed someone in Arizona, the city of Pittsburgh went back to the autonomous vehicle companies in town, and they decided to do a complete review, and they realized that the autonomous vehicle companies weren't being completely honest with them, and they were a bit of a liability. So what they did is they formed a community group, and they put this charter out there. So we spoke to both the city of Pittsburgh in terms of what they did in those interactions, and we also actually spoke with Uber, who were actually pretty open about that experience in Tucson and the impact it had in terms of what they were doing in Pittsburgh. And both of them talked about it in a positive manner in terms of what they would do going forward. All right, so now we get on to what we're doing here in Australia. So there were two things. So we looked at about 100 towns in Australia in the 15 to 25,000 population range. We ended up choosing Karratha for a variety of reasons. But also what supported that was the fact that it was in the Pilbara. And the Pilbara is probably one of the great undeveloped areas in Australia. So I compare it to Arizona and the tech city of Tucson. So Tucson is hotter in summer than Karratha, and colder than Karratha in winter. In fact, it gets down to freezing, so it doesn't have any good weather any time of the year. It has nearly 1 million people in it, and the state of Arizona has nearly 7 million people, versus the Pilbara with 64,000 people. And so it shows you that there's huge potential there, and you can put a tech city in a place like Karratha and do good tech. That has nothing to do with the weather, because that's the reason people tell me you wouldn't go to Karratha. And the value of the industry in that area means you can be very close to what's going on. But Karratha itself. So the reason we liked Karratha is that it resembled a large city on a small scale. So it had a central business district and 5 distinct suburbs. The demographics were great in terms of what we were doing. The weather was good for testing equipment. We brought the Americans over. They loved the place. They said this was ideal for the kind of testing that we were doing, particularly around autonomous vehicles at the time. So this was a really good place to start. Now, originally, when we set up our living lab, we were doing autonomous vehicles, and so this was with Andrew Forrest and Fortescue. Now, ultimately, we weren't successful in this, and there's a variety of reasons for that. One of the key failures was the regulatory reform process. We just couldn't get the approvals required to do what we wanted to do on a globally competitive scale. And some of those problems still persist today. But at the end of it, when Fortescue pulled out and they went off and did autonomous vehicles on site where they didn't have to worry about those regulations, we had a very good model. So we still had a lot of partners who were interested in doing something. So we decided to refocus our efforts from that. And a lot of the partners we had wanted to then branch out into what was going on in the resource sector and how we included that in that process. So we picked a few things. So one of them was mobility as a service. And So the reason we chose this one is Karratha is pretty well a blank sheet when it comes to transport. There's a few things we wanted to model and some new technologies we wanted to trial. And the public transport system they have in Karratha is you have a 54-seater bus that they take from Perth, and it goes up to Karratha on a fixed time, fixed route, conventional process. Now, the cost of transport, public transport in Perth on a bus is $1.20 per person per kilometre versus, say, Sydney, which is currently the best in Australia at about 95 cents per person per kilometre. So, you know, it's not terribly expensive, but it's not terribly cheap. When you compare that against Uber, Uber is $2.11 per person per kilometre per trip. Now in Karratha, the cost per trip is $100 per person per kilometre, and that is $100 per person per kilometre, so it's ridiculously expensive. So we created a model where we would put in 6 15-seater buses and do a on-demand public transport, and we would get that down to, we modelled at $3.86 per person per kilometre, which not as cheap as Perth, but clearly much less than $100 per person per kilometre. So this was some interesting things that we now found out as part of this process when dealing with regulations in government. And so the government gave us many reasons why we shouldn't do it. A common theme from the WA government was, can you do it in Queensland? That came up quite a few times. So they didn't want us to do it here, and they wanted someone else to go through the heartache of doing that. All the way through to, we only do projects in Perth. And the one that struck me as quite bizarre is that they said, look, our concern is this will be so popular that we'll have to roll it out, and that's against our current model. And so we'll do everything we can to stop you. Which was odd, but the missed opportunity there, and it's still on the cards for us to look at, is we really wanted to model a new fleet management system for mining. So if we go back to the map of Karratha, what we thought is we wanted to create an Uber-style fleet management system where it's not on vehicle optimization, it's on the ore optimization, and then we could simulate what people were versus that. Now, if we were to do this on a mine site, it would take about 5 years to get the data, and then we'd have to do it on multiple mine sites. And anyone who's done a research project on a mine site will know that it's extremely difficult to get one mine site, let alone multiple here. So what would take us 5 years, we could do in several months in Karratha. So the example we give for that is we recently did a try local app in Karratha. And so this is, instead of giving out vouchers, it's an app where you go into town, and as part of the COVID-19 response, and all the residents get a voucher on their phone that they go in and do that. And so in a very short period of time, we had 6,000 people sign up for the app and then start to use it in ways that we never ever conceived, which is good. I mean, it caused us a huge amount of grief in terms of things they were trying to do with this stuff. But you're talking, if we were to do something similar for a process in the resource sector, you know, that would take 5 or 6 years, and all of a sudden we had that amount of data and that amount of research done in weeks. So that was quite interesting. The other one we looked at, and we liked electric vehicles because we didn't have to deal with any regulatory hurdles, or not so much, around this, and because it was an interest in mining, this was quite good for us to look at in that respect. So it was fairly simple, and it's probably a little bit. There's one going on in Canberra at the moment where they're adding 200 vehicles into a city the size, 250,000 people, and we'll do a similar number of vehicles in a town the size of 25,000 people. So we should see a much bigger impact in a much shorter time. And the key difference there is we want to connect it to the grid, which they can't actually do too much in Canberra at the moment. So that'll be interesting from that perspective. And that will allow us to not only solve some key challenges in terms of how you connect to the grid in an urban environment, it actually allows us to solve some challenges that the mining companies have as well that we would model at that particular point in time. So it's pretty simple. We used the electric Kona. We thought that was the most suitable electric vehicle for the Pilbara. It's pretty price effective at about $60,000. And in my mind, it's a much nicer vehicle than the Tesla 3, which sits at 100k. It's a much more versatile vehicle. And it's got a decent range on it. It's got like a 500 kilometre range. And so what we did is we combined it with the energy bill that you have in Karratha. So, you know, the energy in Karratha is very expensive. And what we could do is we could offer half price power and wrap it up into the second vehicle that the house owner would actually have. And then we could do a call for recharging back into the system. The way we did that is through some apps. So working with Horizon Power, who actually have an app that does this, and Hyundai, who actually has an app for their electric vehicle. It's combining those two through some APIs and working at how you actually do that. So that allows us to then do some real life modeling on how that would actually work within the mining environment from an electric vehicle perspective, and deal with things like range anxiety and those kind of components. Now, why is this important to the mining industry? So if we look at global trends, so this is from the VCI State of Play, and number 2 on the list is energy transition. So this is the first time energy has even appeared in terms of a global trend. And so we can see that, I mean, Goldfields recently, one of their mines went completely clean energy, wind, solar, and there's a number of mines currently following them that'll go completely off grid as well. So it's a trend. I think there's something like 300 to 400 megawatts of solar panels being installed by resource companies in the Pilbara alone this year. So it's definitely heading in that direction. And to model electric vehicles on site will take many years, whereas if you model it in a specific location with mining in mind, then you can do a lot more work. So part of the Living Lab process around that is actually identifying the challenges that mining have and focus on them in the Living Lab, so that then those organisations can take those learnings to their prime customer, being the resource company, and we don't have to even deal with them. So VCI had a workshop, and so this is some of the outcomes from that. And so from a miner's perspective, and there was quite a few mining companies involved in this process, and so this was part of the Future Battery CRC workshops, and they wanted to know was how does it work on their side? How do you accelerate the product and innovation? How do you align it with your clean energy components? And so that was a key one, is the mining companies wanted to put in clean energy before they put in electric vehicles, because they didn't want to power up their electric vehicles with dirty power. How do you share the risk, and how do you align your utilities provider with clean energy options? Whereas the people providing services had a whole series of other challenges. Probably the only one we struggled with was heavy mobile equipment, and that's because technology is not available to do that currently. But in terms of all the regulations and the OEM's perspectives, we could model all those techniques in a town. Not only that, we could train up the local workforce who actually provides services to the primes to do all the work for them in that respect. And that's everything from micro-credentials to working with TAFE and all those components associated with that. And so that was an interesting challenge for us as well when we first approached Hyundai to get 100 vehicles, electric vehicles for Karratha. They wouldn't sell them to us because they couldn't service them. They said we had no one who could service that amount of vehicles in the state, let alone in Karratha. So these are some of the challenges that we face in that respect. One of the other things we looked at over 12 months ago that we struggled with from a regulation perspective was putting in smart infrastructure, and so there was quite a variety of reasons for that. And one of these was to build a new transport system monitoring process for the resource sector, as well as understand the impact of autonomous and connected vehicles in the wider community in that respect. So this is a project that we looked at in Karratha. We were told to do this in a paddock. And this is another project where the Department of Transport in Western Australia told us to take it to Queensland. Department of Transport seems to love Queensland for some reason. So we did actually. We started having conversations with Queensland. If it wasn't for COVID-19, we may have actually had a project in Queensland this year around this. So this is the current leading traffic management system in Australia. You have an analog control box, And this is SCAT. Anyone who's not familiar with SCAT, this is the current version of SCAT. Looks like it's done on the Commodore 64. Now we want to replace it with this, with a digital controller and a state-of-the-art real-life camera-based traffic system. Now we modeled that you can improve traffic flow by up to 20% by putting in a system like this versus the old static system you had from SCAT. In the end, we couldn't do it in Western Australia, which is why we looked at doing it in Queensland. That's where the Q come from, Queensland Future Mobility. But this is something that we wanted to trial before we took something like this into mining in terms of a vehicle monitoring system, simply because we could learn more in a year than we'd learn 10 years in mining because of the adoption curve that you face in mining in that respect. And if we brought in some companies who could actually bring that technology into the mining companies, across multiple mining companies, then we didn't have to go and talk to every individual mining company themselves in that respect. All right, so this is where we get into the business end of how the Living Lab actually works. And so this is modeled off the US model, and particularly a lot of the work we did in understanding how Pittsburgh actually worked from a cluster perspective. All right, so this is a model that I developed a few years ago. I delivered models similar to this recently with a Myra Global. I built a model based off this for the CoLab program. But what we can see here is that Australia is very good at this topic. We have a long history of doing good research. We produce significant papers, and then we get more money to do research. So that ecosystem works extremely well in Australia. The CRCs are a prime model for this, and that's why we target them, is the CRCs do this extremely well. Where Australia is not so good is the bottom bit here. And so this is the Living Lab component and where we focus. And that is taking the bit that we want to do and take that idea and then develop it for commercialization and then get it out there into the marketplace. So this was our focus on getting the Living Lab to work with us. And so this is where the researchers sit, and the tier below this, which we also don't cover, is probably where the primes sit who buy the end technology. And so most of the technology we managed to go through this entire process we've actually done without actually talking to a single prime in this space. So we have a standard ecosystem model. This is anyone who's familiar with the startup process will see something similar like this, and it doesn't change too much. You have the ideation from the research that comes out. Now, what we've done here is we took the research from the various CRCs, and we took it into town, and we went and saw all the SMEs, the engineering firms, all those organizations out there, and we said, here's a list. Now we mapped 14 different CRCs in terms of all their programs, so everything from offering them PhD students to educational programs to actually being involved in projects and commercializing IP, so we covered a lot. Now they were doing things, suggesting things I'm doing with the IP out of these CRCs we didn't even conceive, and they would say, look, we have customer Rio Tinto or customer BHP or customer Woodside who would like to do this. We didn't even know this technology was available. How do we get onto it? I'll take 5 PhD students and that kind of stuff. So what we saw in that process, and this was amazing, is that if we tried to take PhD students and we spoke to the 5 primes in the region, we might get maybe 3 PhD students a year on an average of 3 months into the region. After talking to all the SMEs in town, we think we can take that number to anywhere between 20 to 30 PhDs in a town in a year, compared to if we'd gone to the other end of the scale. So that's quite phenomenal in terms of how many PhD students we think we can fit in a town of 20,000 people. And if we expand that into Port Hedland, then we might get up to 30 or 40 PhD students in that region, which is incredible. I mean, they were saying, some of the SMEs were saying they would take 2 or 3 for up to 4 or 5 months to solve specific problems. In fact, they had a long list of problems and then started to come back to us with weird and wonderful ideas of what they would actually like to do. Then we go through a validation process, then the development, the commercialization, scaling, and clustering, and around that process. So cluster, this is a foreign concept to Australians. What we're saying is that you need to cluster as a region. So when we first went into the town, they were like, yes, we would like to work with you and the CRC, but exclusively, you've got to sign an exclusive deal with us. Now, these are SMEs with maybe 100 or 200 employees at the most, down to, ones with half a dozen people in it. And so, we were saying to them that, well, what you need to do is you actually need to all work together to cluster as a region and support each other in that process. Now, as far as a prime is concerned, if a part leaves their gate, they don't care whether it goes to Melbourne, Brisbane, Perth, or wherever, as long as they get it back for a price that is reasonable. So if it leaves the gate and only goes as far as Karratha and then goes back in, they don't really care in that respect. And so that was the conversation that we had with them. We told them that we need to work with government on some of the stuff that we're doing. So things like one of the companies in town wants to build a galvanizing plant in Karratha and having a huge amount of trouble in doing that. And they were saying, look, we can do this piece of the puzzle, but we can't do that piece of the puzzle. So we were able to create a very simple ecosystem to say, look, if you work together with this company, then you can actually create a better product together in that respect. So this is where we started to engage directly with the resource companies without actually even talking to the resource companies. So this is the first step of the process. What we wanted to do was show them the funding pathways to actually do this. Now, some of them were aware of some of the basic funding that were out there in terms of grants and that kind of stuff, but they were absolutely amazed at the variety that was out there, particularly working with the CRC. And the funding and grants you can get in that process. So that was an eye-opener for them. They were very excited about that. As I mentioned, the collaboration building, working together as opposed to against each other, and then picking the right location at which to do that. Now, it was actually easier. They did all the work for us in terms of finding an output for the product that they were developing, because they already have a market with the primes in the Pilbara. And they said, yeah, if we can do this, we can sell this product to this major mining company here. So that was a good process in that respect. The next one is actually where we are today. This is about validating the model and the information they're actually giving us, building the product, testing and retesting, and then approvals and regulations, which is not goes against every bit of equipment, but against a lot of the stuff that we're actually doing in the town. In that respect. And so we've just started on this journey, and so this will be the focus for the next year is building this part of the model and seeing how that actually works and some of the impact that it's going to have. And so this is actually where we actually start to engage with the primes in the Pilbara in that space. And so this is the last step in the process: scale and deployment, funding, regulation deployment. Now, so I'll just talk about the funding here. So I hear a lot about getting capital in Australia and how hard it is, and a whole series of challenges associated with it and stuff like that. So I did an exercise last year, is created a company, and we made a product. And then I went out to 25 different VC firms to see whether I could get funding for it or not. So out of the 25 we spoke to, only two or three didn't actually get back to me at all. About 15 of them suggested that they liked the idea, they liked where we were heading, but we were pre-revenue. So if we could make some revenue from it, then they'd come back and talk to us about funding the project further in that space, which is definitely where we would go through at this particular point in time. Only two of them said, we only deal with software, not hardware, so we're not going to give you any money, which was a big complaint from industry when we spoke to them, but we didn't find that was actually true. And we had two that would actually give us money for this product, which we thought was pretty good. Now, ironically, those two VC firms were not, they had a presence in Australia, but they were not Australian focused, and they were not there. The other thing we found out in this process is, I've raised capital in the US, is that the rates you get in Australia for VC capital are terrible compared to what you get into the US. So I would still go to the US to get capital over some of the VC firms here. So an example of that is that if you're after $3 million, a VC firm in Australia might want 30% of your company for $3 million. If you go to the US, they might only want 5 to 10% of your company. So that gives you an indication of where that market currently is. So anyway, we have a network now of VC funds that said if you go through this entire process here, this is like a validation process for a due diligence, and if you get to this particular point in time and you can show the market there, then we'll invest at this particular point in time. So that works quite well for us in that respect. All right, so that basically finishes the presentation this morning in terms of where we are at with the Living Lab, the impact we've found, and where we are in terms of this journey. So I think it's time to hand back.
Thanks very much, Paul. It was a fascinating insight into the work that you're doing, and certainly quite diverse in terms of kind of the areas that you're working in, and the links back to the mining sector. So thank you for that. So if anybody online has any questions, please feel free to type into the question and answer box. I don't know, Rick, if you had any questions or anything that sort of took your attention from the talk that you'd like to.
Well, the one thing that I guess was a little bit sobering was the response you were talking about from the government, where, I mean, the impression, maybe I got the mistaken impression, but it was like this was more of an inconvenience than it just feels like we pay a lot of lip service to being very smart and forward looking and everything, but it sort of feels a little bit like the response you got was yes, but not if it's inconvenient.
Yeah, that was surprising. Yeah.
How do you think we get around that?
Oh, good question. So I wish I knew. Perseverance goes for a lot. So, a lot of the stuff we're currently doing now, we were told 3 years ago were impossible. So a lot of it is you're just going to keep chipping away and build support for that. Some of it is just simple as you just move to a different state. And you see that in a lot of the US, if you have trouble with one city, you move to another city. They compete against each other quite effectively. We don't seem to have that kind of process here in Australia to do that.
Right.
I suppose one question I was going to ask maybe was, you sort of mentioned about the transferability into the mining sector. Do you see these same sort of clusters or living labs in different sectors, so in farming or other kind of forms of sector that require the same kind of involvement?
Yeah, so in the US and Europe, transport is a big component for these living labs. Clean energy is a big focus. Recycling is a big focus. There are agricultural living labs. In Australia, previously, living labs have been focused on transport and continue to be focused on transport. UWA just had their living lab, which is the first one with a mining maintenance focus that I've seen. So they're popping up across multiple sectors, although in Australia, they are very, very different from each other, and there's no kind of formal process that brings them all together.
Just focusing back on the mining sector, do you see, I see obviously you've been highly involved with Mets United. Were you involved in the early stages of their living lab kind of ideas in, I think it was like 2016? How well have they come into fruition? And for example, like a research institute like us, how could we engage better with living labs that are kind of more mining focused, and how we could sort of engage with those kind of sites?
Yeah, so this is where a lot of the work that we've done with a lot of those research organizations is to talk about how we get them involved in a living lab. I think that was one of the things I wanted to do at Mets Ignited, but I just couldn't get it off the ground. We've had some very good chats with ANU and UTS, ECU, Swinburne were all very keen to be involved in a living lab. They had their own views and agenda of what they wanted to pull out of it, which was pretty good. The concept is quite foreign. I think the fact that we focus on dealing with the primes, the Rio Tintos and BHPs of the world, is always attractive. And in the past, it's certainly been a path that I've looked at, that cashed up. But the reality is you can move much faster in a living lab environment by working with the 50 organizations that support those primes. They're the ones who are going to push the new products in. You are not going to do it themselves. And if you produce a new widget for a big mining company, they're not going to do anything with it themselves. They want someone else to do that component. And so that's the thing that we forget, is that the mining companies themselves are the consumer and not the producer in this particular point in time. And another sad fact about the Australian mining community is if you do deal with a prime, they will quite often try and lock you into some sort of exclusivity, which is always a challenge when you're trying to run a business in that respect. So if you avoid that by not having the conversation with them and you talk to all the suppliers and you build a cluster, then that gets around that challenge.
I had a conversation recently with somebody he's no longer with a big company, but was with a big company, doing in that sort of innovation space, and their comment was that that you guys as a research institution, you think you're spending big money and putting big efforts into this area, but let me tell you that our effort was like 100 times what you were doing. It was all internal, all in-house, and it sort of set me back to suddenly think, that there are these enormous efforts that are going on that can continue or just get cut off if the company changes tack. And you always wonder how much has actually been done internally that never sees the light of day. And I don't know, this is sounding more like a comment than a question, but have you run into that? And do you see a way forward that we can somehow get more serious investments from big players into these sorts of collaborative efforts?
Yeah, actually, that's a very good point. So about 6 years ago, I looked at, when I was head of innovation and technology for Goldfields, we did the same. We would spend huge amounts of money on projects privately, and if it didn't quite get there, we put it on the shelf. Now, that doesn't mean that it wasn't successful or would be successful else. It's just that we had finished with it. We put it on the shelf. So I spoke to my peers in the industry, and there was a massive amount, hundreds of millions of dollars worth of IP sitting on these shelves. I looked at a process that we could get it out into industry, but it just seemed like a bridge too far to do that. So one of the advantages of doing this model as opposed to that model is you are doing most of the bulk work before it goes into a big resource company, which means if it doesn't actually work, you can still reuse it and it's still valuable to someone else. And that's effectively what we've done. I mean, if we had done this project 3 years ago internally with an organization, we'd be dead. It would just sit on a shelf and we couldn't do anything with it. But with every failure, with every block, we've been able to grab it and take it to its next iteration in that respect. So, we started off doing autonomous vehicles. That didn't work. But the entire model and all the work we put into it is now being used to pump out technology and PhD students from CRCs, and that's a great outcome in that respect. So I think once we've got a model like this set up, then it's good for bringing in new projects. You said we have this entire ecosystem. We're connected with all the SMEs. We're connected with the primes, and we can channel that technology and grow it fairly quickly in that process. So we have been approached by Queensland to do one there. And we have been looking at locations in Queensland on where we would do this. But, we said, look, let's wait another year. Let's get Karratha through the next stage and take some learnings from that. And if it's successful, then maybe we'll look at doing one on the East Coast as well.
Well, we're certainly keen to be involved if and when the time comes. And there have been sort of, I've been in, it's more like beer coaster level of planning, but discussions around, similar sorts of initiatives. I think there's a lot of you know, there's a lot of sympathy for that sort of approach, but it's been interesting to see just how much how much effort and how much complexity is involved in turning it from a beer coaster into reality.
Yeah, yeah. You know, we the whole ideation process in getting, you know, thousands of users so fast compared to what we were doing in a general mining environment. And even if you do actually do a project with a mining company, they tend to sanitize the results as well when they give it back to you, because that's what you do in mining. I mean, I was no different when I was there as well. Whereas you do something in the public space, geez, they tell you, you know, they put it on Facebook, and you have to deal with it fairly quickly. If you measure if you had Facebook for mining and then your employees told you what they really thought, that's kind of what it's like working in the general public.
Okay. Oh, thank you again, Paul. It was really, really great to have you joining our seminar series this year. So for now, I'm going to sign off soon. I'm just going to say next week we have Associate Professor Gavin Mudd from RMIT, and he's going to be talking about a question he's posed. And he says, oh, well, really, he says it's still about the environment and some great ideas for sustainable mining. So we look forward to having Gavin with us next week. So again, thanks everyone for joining us online, and hopefully we'll see you next week. Thank you.
Thanks, Paul.
Thank you.